So this is my new video regarding the structural isomerism. So let's start with this new video. What is structural isomerism? Basically, for a given molecular formula, there may be different type of arranging these atoms, and this is known as the structural formula. Like the molecular formula C3H6 have following different structures. There are three different structural isomerism: positional, functional, chain isomerism. You can see here the line is showing the C3H6. It can be ethene, simple 1-propene. It can be also 1-propene, or it can be this one as well. So different structures, cyclopropene. So different structures for the same molecular formula. Position isomerism. In the position isomerism, the position of the functional group may be different. You can see here the bromine is here, or it can be 1,3, 1,2, 1,1, 2,2. So basically, or here we can see it is 1,2, again 1,2, or again 1,2. So this is known as the positional isomerism, meaning the position of the of a group is different. Functional group. In this one it is OH. When it is OH, it is actually propane 1-ol. But if it is O between two carbon atoms, then it is a methoxyethane. It is an ether actually. So this is a functional group isomerism. Chain isomerism. This is straight chain. This is a chain formation, butane or methyl propane. So this type of isomerism is known as chain isomerism. Now the main important part, which is stereoisomerism. In the stereoisomerism, compounds whose molecules have the same atoms bonded to each other, but with different arrangements of the atoms in the space. There are two kinds of the stereoisomerism. It can be geometrical cis-trans, or it may be optical. In the case of the geometrical one, like you can see here, this is 1,2 dibromoethane. It is cis. Cis means the two same groups are of one side, one opposite side. Like you can see bromine here, hydrogen here, hydrogen here. If this is a case, it would be cis. But if it would be a case in which it is across, it is known as the trans one. As there is no free rotation about this bond because of the presence of pi bond. In CC bond, geometrical isomerism is not possible because there is a free rotation. Acha, okay. Whenever we have unsaturated compound with the structure shown, we can have this geometrical type of isomerism. You can see here, it can be like this one or this one or this one. All of them are considered as a type of isomerism. And this is cis, cis, cis. Okay. Now there is another type of isomers which is about the cyclic compounds. You can see here cis 3-methylopentanol and trans. This is cis 1. This is trans 1. Trans 3-methyl cyclopentanol. Cis trans. The same difference, either on the same side. Like in this one, it is on the same, like towards you. It is one of them is out of the paper and one of them is below the paper. Again, you can see here. Another example is a substitutory compound of cyclobutane with two groups substituted into 4-member ring. The two geometric isomers below are called cis and trans cyclobutane. You can see here. This one. This one. This is the cyclobutane. This one is cyclobutane. Cis. This is a cis isomer. This is a trans isomer. Another one you can see here. Another one you can see here. Basically, these two are the explanation of above one. These two one. Okay. The last one is another example is the geometric isomer below are the cis and trans cyclobutane 1,3-dicarboxylic acid. Again, it is one is out of the paper, one is above the paper. Both of them in the cis isomer, the two carboxyl group are either both pointing above or both pointing below the ring. In trans, one carboxyl points above the ring and one below the ring. So this is a further explanation of the same thing. You can see here is OH on the upper side and here OH is on the lower side. So this one is trans while this one is cis isomer. So these are the further explanation of this one. It is a different one. Optical isomerism. In optical isomerism can only be possible if there is a carbon atom Like the two different optical isomers called enantiomers are mirror images of each other and they cannot be superimposed. So these are two of the mirror images of each other. This pair of molecules are optical isomers referred to as enantiomers. Trying to superimpose a two isomer is like trying to superimpose your left hand on the top of your right hand with them both facing downward. It cannot be done. And there should be a chiral carbon atom for optical isomerism. If there is no chiral carbon atom, then optical isomerism is not possible. Okay. Optical isomers differ in their effect of the polarized light. Normal light is unpolarized. It can be thought of fluctuating electric and magnetic fields vibrating at the right angles to each other in every possible direction. So one will rotate the plane of polarized light clockwise and other anti-clockwise. It means that one of the optical isomer rotate the plane of polarized light to the clockwise while the other one to the anti-clockwise. As well as straight and branch and molecules, substituted cyclic molecules can also be chiral center in their ring. To decide where the chiral centers are, we still have to find any carbon atoms that are bonded to four different atoms or groups of atoms. Look at this example of substituted cyclohexane molecule. You can see here the two hydrogen, so it is not chiral. Again, two hydrogen, two hydrogen, two hydrogen, so these are not chiral. But the purple one is only one hydrogen in the whole of this group, then whole of this group. So this one is chiral and this one is chiral. So it means that it will show a kind of isomers, optical isomers. The fourth bond from the carbon atom will be attached to this group. So the original carbon atom has four different groups or atoms bonded to it. Hydrogen atom, OH atom, CH2 4, CHNA2 group, CHNA2, CH2 4 group. So same thing I have already explained earlier. Okay, with this one, now we have some examples to explain the whole of the topic. In this warfarin, which is the red poison, so how many chiral centers? So if you see here, all those with the yellow markings, either have a double bond or two hydrogen, so they are not chiral. Only this carbon atom with a purple one, it is a chiral because it is connected to four different groups. You can see here, it's a whole different group, 1, hydrogen 2, and this whole group 3, and this whole group is 4. So answer is B. There is another one. It is anti-asthma drug inter disodium chromoglycate, which has the structure below. So in this one, basically all the purple one, they are not chiral, while one in the yellow one, if you see closely, this one, it contains H, OH, and on both sides it contains CH2O, CH2, so it is also not chiral. So answer is 0. There is no chiral carbon atom in this molecule. Okay, the compound of a molecular formula shown exists in two forms. What are these forms called? You can see they are the optical isomers because they are superimposed upon each other. They are not superimposed upon each other. They are enantiomers. They have chiral carbon atom. They have the capability to rotate plane polarized light in the opposite direction. Here we have another one. This is what kind of isomer is this one? Now you can see this hydrogen is on this side. It should be like on this side, like this one. As it is not on the above side or not on the lower side, so this is not a cis or trans isomer. It doesn't have any chiral center. So answer is D. It only has a structural isomer. Now this one, Yanucamide B can be extracted from marine sponge, which is which combination of the number of chiral centers and of ester linkages does it possess? You can see here the purple one. The purple one are the carbon atom which have four different groups. You can find out yourself as well, like this one. One group is here, other group is here, one group is here, and one is hydrogen. So same thing with this one. So 1, 2, 3, 4, 5. 5 are the carbon atoms, while this is C double bond O single bond O. This is ester linkage. So there are two ester linkage. That's the reason answer is 2. And that's it for the video for today. See you in the next video. You can contact me on this number if you want to ask something else. Thank you very much. Allah Hafiz.